welcome grade 12 mindsetters. As you know, you have joined us here on Learn Extra Live, and we are doing maths literacy with Peter. Hello, Peter.
How's it? How are you doing?
Good, thanks. How are you?
I'm always good, always good.
Me
always
too.
Good.
Me too. Tell us what we'll be doing today.
Today we're going to do a bit of stats. Exactly same sort of principles we did with the grade 11s earlier.
Okay.
But now we're just going to take it a few steps further.
Okay.
And hopefully, you know what, grade 12s, let me just tell you this. You should be watching the grade 11 and the grade 12 sessions. You really should. Because the grade 11 is just giving you a bit of recap on what you would have done, or should know anyway, and then it leads on to the grade 12 work.
Yes.
And it's so important, especially knowing this, that you could get questions in your final matric paper that are similar to the work we cover in grade 11.
Yes, that is quite interesting.
Absolutely.
So to get all your marks, ensure that you're watching us from the grade 11, hey?
Absolutely.
And also grade 11s can also still join us. They mustn't run away as well, hey?
Yep, no, they should also just join us.
Okay,
They're more
cool.
than welcome to. So if you're in grade 11, you hang in there as well.
Awesome.
Okay. Tell me, Kat, just one thing I want to know. How
Okay.
do you get here?
By car.
Do you?
Yes.
Okay. I was speaking to our producer earlier. She
Yes.
has to get here by car.
Okay.
And she was complaining about a problem that's with her car. She says when
Okay.
she drives, there's a loud banging.
Oh, no.
Oh, no, it's terrible.
Yeah.
But the good thing is, she says, as she turns the radio louder, the banging,
The banging
goes away.
goes away, yeah,
It's
of course,
amazing.
of course,
okay.
yeah.
Are you going to tell her or am I going to tell her?
You
We
do
just-
it, you do it, you do it. I
Alright,
can't
we'll
bet
tell her
you.
later. You tell them about this, I'm going there.
Okay, you go over to the board. So, guys, you know exactly what to do on our Facebook page. And for that, it's facebook.com/Learn Extra. Twitter handle as well @Learn Extra. Ensure that you blast the Facebook page. As you know, yesterday was 15,000 and today we have over 150 more over the 15,000. So make sure that you also are part of that, guys. It's great to be part of our Facebook page because then you can ask us any questions that you wish on maths literacy. And as you heard, today we're doing statistics, and I know statistics is a lot of fun, and I know that you also have a lot of questions. So that's what we're here for. Hey, Peter.
Absolutely. And in our last show, we had quite an interesting little thing happen.
Yes, we did.
Which kind of surprised me. Suddenly, on air, live, were my folks
Yes,
talking to me, which
yes.
was really incredible.
was
I want to tell you something about my folks, though. It's quite funny. We were trying to give them a holiday, and we were going to send them all over to America.
Okay.
And my mom said, there's no way I will ever go to America. And I
Why
said,
is that?
but why? She said, because they drive on the wrong side of the road. They drive on the right-hand side. And I tried it the other day in Durban, and it was horrendous. Okay? And my dad looked at me, and I looked at him, and it was like, okay. And so if there are any panel beaters in Durban who are listening, please give me a call. Write into us. We've got a job for you.
Yes,
Okay.
we do indeed.
Guys, let's get on with the first question. All right, so our first question of the day is this. If you look at it carefully, you can see that we've got some sweets. In fact, let me just get up the real question. All right, so here is calculate the total number of items sold at the tuck shop in one day. So what we've got is we've got a group of guys who are trying to raise some funds. And they go out and they now decide they want to see what the tuck shop's actually doing. And so they come up with a whole lot of data, and this is the data they actually come up with. They see that on a daily basis, and please take note, guys, this does say daily, all right? So on a daily basis, 198 sweets are sold on average. Mugs of coffee, 18. Obviously, it's not winter in Joburg where this was
Yeah.
done, because otherwise there would have been a lot more mugs of coffee. Okay. Mugs of tea, 12. Can of fizzy drink, 22. Bottle of fruit juice, 110. Here's a great question, which I know doesn't come up, but here's a great level 4 question. Would you say that these sales are referring to a winter season or a summer season? Explain why. And I would say definitely it refers to a summer season. Because if you look here, you can see the number of cool drinks that are sold. 22 fizzy and 110 fruit juices compared to only 30 cups of tea or coffee. Okay.
True.
Nice kind of question, got nothing to do with what we're doing today, but I thought I'd throw it in there anyway.
But
Talking
Peter,
about throwing it in
People drink orange juice, and that's the fruit juice during winter for
Do they?
vitamin C. So
there.
just to throw a spanner in the works there.
Okay, ignore Kat. I'm the teacher. Right, let's go on. Sorry, Kat.
That's okay.
Talking about throwing things in there. After the break, we are going to throw in a challenge question for you. All right? We had one for the grade 11s. It was really fun to try and do. It was quite a difficult thing to tackle. So what we are going to do is we're going to do a similar sort of question for the grade 12s. But we'll discuss that after our first break, and then you'll be able to tackle that one. But for now, let's have a look at this. Okay, so there's the amount of daily things that are sold. We got 198 sweets, 18 mugs of coffee, 12 mugs of tea, 22 fizzy drinks, and 110 fruit juices. They've given us that same data on this sort of chart. What do we call this? We call this a pie chart. And you will see that they've said fruit juices make up 31% of their sales. Coffee 5%, tea 3%, fizzy drinks 6%. Sweets, we're not sure how much percent it makes. And I bet there's going to be a question saying calculate that percentage later on. Okay, so let's go now and look at the questions. And I'm going to be jumping between two different screens here to make life easier for us. Calculate the total number of items sold at the tuck shop in one day. Okay, so all we've got to do, and guys, this is a straightforward question, hey? This would be a level 1, like paper 1 type question, because you can't get it any easier. How many things are there? All they're asking us to do is add them up, and that's what we're going to do. So we're going to take our calculator, and we're going to add up those figures, and I'm going to move my calculator just so that I can see what I'm adding. We got 198 plus 18 plus 12 plus 22 plus 110 equals, and we get 360. So my answer to that question is 360 items are sold every day. Okay? Are we happy? Let's look at the next question. My next question. Calculate how many bottles of fruit juice they can expect to sell over the next 5 days. Well, let's look at the data. Fruit juice, here it is, and as Kat so wisely said, it could also include orange juice, and people do drink orange juice in winter, so yeah, okay. So we got 110 bottles of fruit juice. How many can we expect to sell over 5 days? Well, if we sell 110 in one day, calculating how many we sell in 5 days, that's quite simple, isn't it? Of course it is. What are we going to do? We are just going to say times 5. And 110 times 5 is going to give me 550. So on our answer over here, we are going to write 110 times 5, which is 550 bottles of fruit juice. Let's move on. Next question. Calculate the percentage of sweets sold. Right, folk. Now, soon as we hear the word percentage, right, one thing jumps to mind instantly. Not holiday, okay? The one thing that jumps to mind is 100. Percentage means out of 100. So we know all these figures, 31, 5, the 3, the 6, and the whatever this is, must add up to 100. So how do I calculate this percent? All I'm going to do is I'm going to take out the calculator again, and I'm going to say, right, with my calculator, and now I'm going to move it this way, we know everything's got to add up to 100. We are going to subtract my 31, then subtract the 5, subtract a further 3, and then subtract 6. And that should give me what's left. And what's left is 55. So I know this is 55%. Easy? Of course it is. Let's move on. My next question. Calculate the size of the angle that forms the fizzy drink segment. Right. So we know our fizzy drinks makes up 6%. Makes up 6% of what? Makes up 6% of the 360 degrees. So that whole circle is adds to 360 degrees. We've got a little angle over here. We've got a little angle here, little angle there, little angle here, and we've got a big angle over here. But together those angles add up to 360 degrees. Why? Because they're 360 degrees in a circle. Got that? So 6% of 360 degrees. So I'm going to say percent means out of 100. So I've got 6 out of 100 of is times, you learned that in grade 2, times 360. So with my calculator now, we're going to say, right, we want 6% of 360 degrees equals, and I get an answer of 21,6 degrees. So that is going to equal 21,6 degrees. Okay. Pen. So in other words, folk, this little angle here, okay, that little angle from that point to that point is 21,6 degrees. This angle here, you'd expect to be a lot bigger than that, wouldn't you? Of course you would, because we know that sweets made up such a huge percentage of the number of items that were sold at the canteen. Okay, our next question. Bergen cannot decide on a suitable title for the chart. What would be a suitable title for this pie chart? Okay, well, let's have some ideas here. What do you think it could be? Maybe it could be the percentage of items sold at a tuck shop, or the number of items sold at the tuck shop, or the different types of items sold at the tuck shop. Okay? As long as it makes sense to the data that you've actually got there. Right, move on. Question 2. Public transport is an essential part of the world in which we live. Most people in South Africa cannot afford their own cars, and so rely heavily on public transport or other forms of transport, such as walking. I didn't know walking was a form of transport. Did you know that?
Of course it is.
Is it?
Some people walk everywhere.
But would you call that a form of transport? Well, you must call it a form
Oh.
of transport because you're getting from one
Yeah,
spot
one
to the
plate
other.
gets you from A to B.
Okay, unless someone's carrying you and they're walking, then that's
And
a
then
definite form of
yes.
transport.
Yes. Or you
Okay.
can call it 2 series.
2 series. The legs, 2 series.
Yes, 2 series. Get it?
Okay. You missed my joke last week. I've got to share this. And the viewers,
me.
you know, you might have missed this as well. You know, if you have a bicycle
Yes.
and it stands there and you let it go, it falls over.
Yes.
Okay, do you know why?
Yes. Why?
Because it's too tired. Too tired.
Too tired.
Okay.
Okay.
Let's move on. So the
Okay.
table below is a comparative study of the modes of transport for learners in South Africa, Australia, and the United Kingdom. So let's have a look at this table and try and analyze a little bit of it, shall we? There we've got it. 73.1% of people in South Africa actually walk to school, is it? Of the transport learners in South Africa, or actually just walk wherever they've got to go, okay? 12.9% of people use a car. That's amazing, hey? When you think of the number of cars that we have in the road, I mean, you just think about it. You go stand in the middle of Joburg or Cape Town or Durban or Bloemfontein or Kimberley or Pietermaritzburg. I don't think Pietermaritzburg is a city, is it? I
It
don't know.
is,
But
it
anyway,
is.
the little thing of Pietermaritzburg. Right, but you go to those cities and you just see cars, hey? Especially at 5 o'clock traffic. In Joburg, it's horrendous. And you see cars and cars and cars and cars. And then you realize only 12.9% of the population is represented by all those cars.
Sure.
That's scary.
That is
Imagine
very
if
scary.
everyone used
Had
a car.
Oh, no, we'd
Hey?
never get anywhere.
We wouldn't get anywhere. Absolutely. Right, so 6.4% use the bus, bicycle 1.2%, train 0.7%, taxi 5.3%. I must admit, I thought this figure was going to be a lot higher, this 5.3, because I thought a lot of our population in South Africa use a taxi. And other 0.4. I'm not sure what the other is, like
Other-
horseback riding.
I'm not sure.
I don't know.
Wheelbarrowing.
Wheelbarrowing, I don't know. But there's other forms of transport.
that we don't know
Maybe
about.
helicopter, people
That
coming.
could be, yeah.
Could be, okay. United Kingdom, let's have a look at them. Oh, hello. Look at this, guys.
How many? Yo.
Look at the difference between South Africa and United Kingdom, the people who walk. Now, look at this. How scary is this? The number
Sure.
of people that have cars in South Africa or
More
use
than
cars
half.
compared to the United Kingdom.
Sure.
That is absolutely amazing. Now, this is one I find very interesting. If we look at the train
Yes.
system, South Africa, only 0.7% of our population use a train. And I can understand that because if you really stop and think about it, we don't have such a huge infrastructure with the
Yes.
train. Cape Town, fantastic.
do.
Durban's got a little bit,
us as-
absolutely. I'm not too sure about Joburg. I'm not
Now
sure.
our Gautrain is coming.
Our train's
so,
coming,
yeah.
which is absolutely fantastic. But if you think of the train system in smaller cities or smaller towns, there's not really a train system, is there? But in the UK, there's this phenomenal train system. And I was really surprised that only 11.9% of the population
Sure.
use trains compared to the cars. Because
Yeah,
I know
that's
when I've
very
been to
weird.
the UK, it's
Yeah.
like, give me the train any day. Okay? Number one, it's reliable. Number two, it's a lot cheaper. Number three, you don't have to worry about parking. Number
And
four,
but
you
the
don't have to worry
traffic
about
is
driving.
horrendous there as well. So that's probably
Absolutely.
why.
When were you over in England?
I went 2 years ago.
Oh, fantastic.
Yeah.
It's wonderful, isn't it?
It is great.
But
I
it's
wanna
always
live
good
there.
to come back home.
It's always good.
It's always good to come back home. All right. Right. Australia have different sorts of figures. So, folk, I'm not going to go through all the figures on Australia, but you can actually see that you can actually discover quite a bit about the country just by looking at the different modes of transport. Okay. Now, taxi, which I find interesting in the United Kingdom, is 0%. Which I find kind of strange because there are quite a lot of taxis in the United Kingdom. But I think that 0% has probably been rounded off. It was probably 0.03 or 0.05 or something, but it's been rounded off. Okay, so that's why we've probably got 0 there. Right, let's have a look at a few of our questions. We've got a little bit of time before the first break, so let's do this. What is the most popular mode of transport in South Africa? Well, guys, without a doubt, hey, here she is here. Walking, 73.1%. Which is the least popular mode of transport in South Africa? It must be the other. Whatever the other means.
Whatever that other is.
Okay? The donkey or the chariot or the helicopter, whatever, but the other. But if the other wasn't there, then it would be the train. Okay. Right, let's move on to our next question, and here it is. In 2008, there were 1.2 million learners in South African schools. Calculate the estimated number of learners who walk to school in South Africa. All right, so how many people walk around? We said 73.1%. Remember, folk, we've said when we deal with percent, we put it over 100 straight away. Why? Because percent means out of 100. So 73.1% is 73.1 divided by 100. Multiplied by the number of learners who walk to school, which is 1.2 million. Let's write that out, hey? So it's 1,200,000. That's what makes up 1.2 million. Now our calculator does the job for us. And it says, right, we want to calculate 73.1% of 1,200,000. Another 1,000,000 to another 0 there. Equals, and there it is, 877,200. So it's 877,200 learners walk to school on average. Talking about walking, I'm going to walk and get myself a glass of water. So maybe we need a
Let's
ad
get
break.
an ad break. And you guys can also walk over and get yourselves a glass of water. But be sure to be back as soon as you can. In fact, in like a minute, be back. See you after the break. Welcome back, Mindsetters. I told you that would be a really fast break because there's so much for us to go through. And as expressed on the page, there's so many of you joining us today. I mean, we have grade 11s as well joining us. So welcome, grade 11s and grade 12s. Make them feel like they're at home and maybe help them out with the things that they haven't covered yet. Over to you, Peter.
Right, just before the break, we were looking at the way people get around and the different forms of transport. And we actually were astounded by the fact that 73.1% of South Africans actually walk where they have to go. That's quite something, hey? It really is. The other day, my son came to me and he said to me, "Oh, Dad, please will you give me a lift down the road?" And we're talking about 800 meters. And I looked at him and said, "My boy, let me tell you something. When Abraham Lincoln was your age, he used to walk 10 miles to school." And he looked at me and he said, "Dad, when Abraham Lincoln was your age, he was president of the country."
Ah, he
So I
got
put
you
him in
there.
the car and gave
Yeah.
him a minute. It kind of
He
made
really
sense.
got you
Lost that one. Right, folk. We said before the break, or we started the series off by saying that we were going to give you a challenge question in this part of the show. And that's exactly what we're going to do. Before I give it to you, there are just a few things I want to run through very quickly to help you with this challenge question. And here it is. Okay. First thing, we've got to know, what is the range? You know this already. You're in grade 12. If you don't know it by now, you're in trouble. Okay? So the range is my highest number minus my lowest number. We know that, eh? So range is equal to, let me just get a pen here, is equal to my highest number minus my lowest. My median, we discussed this before the break, my median is my middlemost number. Okay, so if I give you a whole lot of data, you've got to arrange it in order from the smallest to the highest. Here's a bit of a hint, okay? So you're arranging the data from the smallest number to the highest, or highest to lowest. It doesn't really matter, but generally we tend to prefer lowest to highest, okay? So you arrange your data from lowest to the highest, and it's the middlemost number. Quartile, now let's go through this, because you were introduced to quartiles only this year in grade 12. So what is a quartile? Well, a quartile is exactly as the name says. It's a quarter of the information, right? So let's say I gave you 5 numbers. Again, we've got to arrange it in order, and that's the important thing to remember here. So if I gave you data, let's say 0, 1, 1, 2, 3, 3, 4, 5. Okay, and I wanted to calculate the quartiles. Now you get different quarters. You get the first quarter, the second quarter, the third quarter, and the final quarter. And so what we do is we break up these figures. 1, 2, 3, 4, 5, 6, 7, 8, and I'm going to give us another one. Let's say 5 again. Okay, so my median, 1, 2, 3, 4, oopsie, what have I done? I've done something wrong here. I've pushed the wrong button. Something went wrong here. Where did it go to?
Did you lose it?
I lost it,
There.
eh?
Isn't it there?
Is it there? No, it's not. Let's go. Maybe it's here. Is it here? No, it's not there. Is it there? I don't know what I've done. I've lost the information. Okay, but let's just go through what quartiles are. So my quartile range is going to be, if I have those numbers, and we said let's pretend I've got numbers 0, 1, 2, 3, 4, and 5. Okay, my middlemost number, and let's give it a 6. 1, 2, 3. Oopsie, I'm really fooling around here today. Everything that can go wrong is going wrong with all this today, isn't it?
Yeah, Peter, I
Okay,
think
there's
it's
my
you.
information there. Right. So if I look at this, I've got 0, 1, 2, 3, 4. My middlemost number will be my 3. Okay, and this is my lowest number, and this is my highest number. This we call quartile 2. Because it's in the middle, right? And my middle, another word for my median, is my quartile 2. It's quarter, the second quarter of my information. The first quarter is that way, the second quarter is that way. But my quartile 2 is my middle. My quartile 1 is finding the middle of my lowest and my quartile 2. So the middle of this would actually be somewhere over there. And I call that quartile 1. Quartile 3 is the middle of the 4 and the 5. It's the middle of my quartile 2 and my highest number, which is going to be 4.5, and I call that quartile 3. My quartile range now is going to be quartile 3 minus quartile 1. So in this example, my quartile 3 would be 4.5. My quartile 1 would be 1.5. So the difference would be 3. 4.5 minus 1.5 is 3. So I land up then with a quartile range of actually being 3. All right. Now I've got to give you the challenge question, and here comes the real challenge for me. And the challenge for me is this, that I've just lost the challenge question.
I think it's there, hey?
You think it's there?
Just where...
Up here, no, it's not there. Up there, it's not there. Up here,
Nothing.
nothing at all.
Maybe
It just
where
all disappeared.
where
eh?
the stickers?
Let's go here. Wait. Oh, maybe I
Okay.
did this wrong.
There. There,
Is that
that's
it? There it is.
That's it. That's it.
Excellent. We're back on track. Okay, folk, do not panic. There's no challenge to this. Everything's under control. All right. So there we've looked at the range median. I explained the quartiles and the quartile range. Now let's look at my challenge question. Here's the challenge question, folk. And listen carefully. If you can answer this, then you understand everything you need to about statistics or about calculating ranges, means, and medians, and modes, and things. Let's have a look. A set of data consists of 7 numbers. Arrange the numbers from the smallest to the largest using the following information. The minimum value is 17. The range is 23. The median is 35. Quartile 3 is 42. The interquartile range is 20. The mode is 22. And there are 3 numbers in the mode. And the mean is equal to 42. Okay. One of the numbers is 45. We're going to make one change. They're not 7 numbers. There are actually 9 numbers. Okay. So a set of data consists of 9 numbers, not 7 numbers. That's
9.
important. So I'm sorry about that error.
Yeah.
Again, what can I do? My producer, we can just
We
only
can just
apologize.
say, yeah,
I mean,
no,
she's-
we already know
anyway.
about her. So.
All right, so a set of data consists of 9 numbers, and back to that information, the minimum value is 17, the range is 23, median 35, quartile 3 is 42, the interquartile range is 20, the mode is 22, and there are 3 numbers in the mode, the mean is equal to 42, one of the numbers is 45. Sure, that's a lot of information there. Guys, like I said, if you can do this, you're phenomenal. So you start working on it, and hopefully
Yes.
you will be throwing the answers
Yeah,
to
please
Kat
throw
very
the
shortly.
answers to me, and I'll be sieving through them, and at the end we'll go through it. Hey?
Hopefully we will.
Yes, sure.
Absolutely. Okay, let's get on with today's lesson, and it was new question. Here it is. The graph below indicates the percentage of medals won at the Olympic Games from 1948 to 2008 for Australia and the United Kingdom. The results for 1980 and 1984 have been removed due to boycotts by major participating countries. All right, so at some stage in 1980 and 1984, bit of political turmoil, and as a result, we've taken those figures off this graph. Okay. I thought this is a great question, especially because we've just
Yeah.
had the
The
Olympics.
Olympics.
Comrades
Yes, yeah,
Marathon,
no,
no
it's the
chance.
Olympics.
Okay. So let's have a look now at the data that's been given to us. Okay. So when we look at it, there it is. It fits on the screen, and let's read that. So the percentage of total medals won by the United Kingdom and Australia from 1948 to 2008. Now, guys, you can see that this graph consists of funny little things here. Squares. Oops, let me just get a nice color. Squares. And then we also have little triangles. Okay. Now, if we look at the key at the bottom, we're told that the squares are Australia and the triangles represent the United Kingdom. So just looking at that, then, what we can conclude is this, that in 1948, United Kingdom had round about 5.5%. They won about 5.5% of the medals. Australia, on the other hand, won just over 3% of the medals. The very next Olympics in 1952, we can see that both Australia and the United Kingdom won the same number of medals, just over 2%, or just under 2.5% of all the medals that were won. Australia won just under 2.5% of them, and United Kingdom also won just under 2.5%. Okay, let's go to the later figures. In 2008, If you look at 2008, you can see here that United Kingdom and Australia won close on the same number of medals. But from that diagram, you can see United Kingdom won just slightly more than Australia would have done. And they're both just under 5%. Okay, so that's the graph we're looking at. Now, let's answer some of the questions that go with that. Right, so my first question is this. In which years did the United Kingdom and Australia record their best results? Okay, so let's find it. United Kingdom, when did they have their best results? So what are we doing? We're actually looking for the triangle, because United Kingdom is represented by that triangle. We're looking for the triangle that's at its highest. Okay, so let's find it. So over here I have a triangle. Okay, let's get another nice bright color. Black doesn't go on black, I've discovered that. Okay, and here's another high one. They're both around about 5.5%, and that's about the highest United Kingdom have done. So their best bet is round about 5.5% of the total medals won. Now, let's find out Australia. And you can see that straight away, can't you? Just stands out. There she is there. 8%. It's the highest little square block on that whole diagram. So Australia had a good year, 1956, when they won round about 8% of their medals. Okay, next question. According to the graph, for how many Olympic Games did Australia win more medals than the United Kingdom? So we want to know how many times, if I had to put it in simplistic terms, we want to know how many times is the little square higher than the little triangle. Now that's been very simplistic, but we're saying how many times is Australia, which is represented by my little rectangle, higher than the United Kingdom, which is represented by my triangle. So rectangle, triangle. How many times is the rectangle higher than the triangle? Okay, so let's go for it. So first thing, not this one. This one's the same, so it's not higher. Here's one over here. Okay, again, let's use a different color other than black. There she is. Over here is another year. They're the same. In 1968, the square is bigger. In 1972, the square is a little bit lower. 76, it's a lot lower. 1988, it's lower. 1992, it's higher. 1996, it's higher. 2000, it's higher. 2004, it's higher. Okay? And in 2008, it's slightly lower. So I'm not going to circle that one. So we got 1, 2, 3, 4, 5, 6, 7 games. In the last few years, since 1948, 7 of those games, Australia won more medals than England actually won. Okay, not good news for England, I'm afraid. But I wonder what happened this year. Do you know that final figure? I didn't
No, I
see
don't know it, eh?
Okay.
We'll find out, though.
All right. But great that South Africa won so many medals.
Yes.
I was quite chuffed.
We did
A total of
fantastically.
6, wasn't it?
Yeah.
That's not bad, eh? Really good. Right. Now, the following data in the table shows a percentage of gold medals won by countries hosting the Olympic Games compared to when they attended the Olympic Games in another country. So, let's have a look at that. So what they're actually saying is this data now represents the following. We are looking at what countries hosted the games and how many gold medals they won when they hosted. At the same time, we're saying, well, when they weren't hosting, how many gold medals did they win then? Is there some sort of pattern building up here where one could say, you know, if you are hosting the games, you're advantaged? Or is this data going to reveal, you know what, you're actually better off if you go to another country? Or is this data going to say, you know what, we don't know whether it benefits you or whether it doesn't? Let's have a look. So Australia, when they hosted the games, they won 31 medals. When they weren't hosting, on average, they won 30 medals. United Kingdom, they won 13 medals when they were hosting. When they were not hosting, they won even more, 30. But that does not apply to this year, folk, all right? This question was actually developed before the current Olympic Games, so I just want to put that out there. Okay. Now, Italy, 36% of the gold medals when they were hosting. When they weren't hosting, 34%. Right. Japan, 55% of their medals when they were gold when they were hosting, 32 when they weren't hosting. Shame, look at Canada, hey? That must have been really frustrating for them.
Ooh,
they were
yeah.
hosting the Olympics and they won
And they-
nothing.
nothing.
No gold medals.
That must have been pretty bad.
That must have been pretty embarrassing for them
Yeah.
and really, really frustrating for the coaches.
Yes,
okay.
of course.
But when they go to other countries, they win 25% of the gold medals, which is phenomenal. United States of America, 44% when hosting, 23% when not hosting. So it looks like United States of America, the Americans really get
They
behind
did.
the athletes. Eh?
Yeah.
China, 51% gold medals won when they were hosting, 33 when they were not hosting.
Because there's so many of them, I guess.
All right. What, so many gold medals? Or
Yeah,
so
of
many
course. So many,
okay. All
so
right.
many everything.
Okay. How many countries, when hosting the Olympic Games, won more gold medals compared to when an Olympics game in another country? Okay. So I'm going to, oops, here we go. I'm just going to try and find the next graph, and it makes it easier flashing between these two screens. So let's do that. Right. So when did they win more games when they were hosting? Well, Australia won more. Oops, let's get a nice color. Australia won more. Italy won more. Japan won more. Canada definitely didn't. United States did, and so did China. Guys, from that bit of information, I would say that when you are hosting, or when a country is hosting the games, it seems they're at a greater advantage. Okay. Right, our next question. Our next question states the following. How many countries that attended the Olympic Games in other countries have a higher percentage of gold medals as part of their overall total of gold medals compared to when they were hosting the country games? Well, it's just going to be the opposite question, isn't it? Now they're saying, well, when did they get more gold medals when they weren't hosting? Well, guys, it's quite simple because it must be the other two countries, United Kingdom and then, of course, Canada. Okay. Right, next one. Calculate the average percentage of gold medals won by the countries that hosted the Olympic Games. I'm going to come back to that question, all right, because I think it's time for an ad break. Before we do have the ad break, I'm just going to run through our challenging question again, just very quickly, so that during the ad break you can do it. The question was, you got 9 figures. The minimum value is 17. The range is 23. The median is 35. Quartile 3 is 42. Interquartile range is 20. The mode is 22. There are 3 numbers in the mode. The median is equal to 42. One of the numbers is 45. Okay.
Awesome.
Time
Thank
for a
you,
break.
Peter. That's fantastic that you went through it. And remember, if you do have questions on the challenge question, don't be afraid to ask, guys, because we are here to help you. So perhaps if you want to ask a thing or two before you actually dig into it, make sure that you do that right now. See you after the break. Welcome back, Mindsetters. As you know, we are doing maths literacy for grade 12s, and it's awesome because we're doing statistics, a deep, deep, deep favorite of yours. I know that. And there's a challenge question. There's always a challenge, and you guys love challenges. So, Peter, please take it away.
Well, it looks like the gremlins have got a hold of us today because things that can go wrong are actually going wrong
Yes,
at the
I
moment.
can
It's
see.
quite scary. So we gave you a question. We started off saying there were 7 digits. There weren't. There were actually 9 digits in our challenge question. That's number 1. Number 2, we told you that the range is 23. It's actually not. It's 33. All right. So on behalf of the producer, she wishes to apologize sincerely, but folk, you know what, the fact that she's got others right, and when you look what she got for matric maths, it's phenomenal she's got this part right. So we've got to say thanks, and we're trying to be positive. But one thing I do need to say is please understand there are 9 digits. The minimum is 17, the range is 33, not 23. Okay, that's important. Median 35, quartile 3 is 42, interquartile range is 20, the mode is 22. There are 3 numbers that are the same as the mode. The mean is equal to 42, and one of the numbers is 45. Okay. Great challenge question, and we're going to come back to that in approximately 8 minutes and 45 seconds. Okay. In the meantime, let's get on with our next question here. So calculate the average percentage of gold medals won by the countries that hosted the Olympic Games. So do you remember just before the break then, we were looking at all these gold medals. And so the question now is find the mean average of all these medals. I keep writing in black. There we go, of all these medals. So how do we do it? Guys, calculating the mean is simple, isn't it? How do we do it? We add up all the figures and divide by the number of figures. And so that's what we're going to do with the use of our calculator. So with the use of our calculator, here we go. We're going to say we've got 31 medals plus 13 medals plus 36 medals plus 55 medals plus 0 plus 44 plus 51 equals, and we get 230 medals. Okay, now folk, I'm going to write 230 divided by. Now, how many bits of information do we have? We've got 1, 2, 3, 4, 5, 6. I've ignored the naught. Or do I include it? Do I say I've got 1, 2, 3, 4, 5, 6, 7 bits of information? In matric exam, the end of last year and the year before, we gave a calculation to the IB candidates, okay, and it could well come up with the government exams as well, but we gave a question where we had 0. And so many students looked at that 0 and pretended it wasn't there. They just turned their back on it. And they said, well, if that's 230, we've got 1, 2, 3, 4, 5, 6 bits of information, we're dividing it by 6. No way. No. You got to divide it by 7 because that 0 is a real number. So when we divide it by 7, we now take out our calculator again and we say, okay, so we got 230. We're going to divide that by 7 and we're getting an average then of 32,86. So 32,86. And that is the average for the number of medals or gold medals that were won when a country hosted. The next question was calculate the mean average of the number of medals that were won when they weren't hosting. So when they were not hosting, okay? So let's go for it. Here they are, 30, 34. So how are we going to do it? In exactly the same way as we did it earlier. So, but we're just using different data. So now what I'm doing is I'm saying I've got 30 plus 30 plus 34 plus the 32 plus the 25 plus the 23 plus 33. And we get equals 207. Again, divided by the 7 countries, and we get an answer of 29,57. So I've got 29,57. So the first question, how many medals were won when they were hosting the Olympics? How many gold medals were won on mean average when they were not hosting? And the final question was this: what is the difference of the mean number of medals won when you're looking at when you're hosting and when you're not hosting? Here it is. 36,86.
Peter, Alona has pointed out, shouldn't it be 32,86?
Was it? Did I make a mistake?
Must we just double check?
Was it 32?
Just in case.
Okay, it might have been 32. I might have copied it down wrong.
Okay.
I tend to make mistakes on the very rare
You are
occasion.
human. You are human.
I am
It's
human.
okay.
This is true. You
Yeah.
pinch me, I hurt.
And
You
you,
cut
yeah.
me, I bleed.
Yes.
Okay, so 32,86%. So sorry, folk. Apparently, our producer was telling me I wrote down the wrong figure. So I wrote 36 instead of 32. Now, how do we find the difference? We just subtract it. So we're going to say 32,86. Let's do that quickly. 32.86 minus the 29.57 equals, and my answer is 3,29. So the difference is, what did I say it was? 3,29. Okay, I'm glad I suddenly remembered that. All right, so there it is there. 3,29 is the difference. Happy?
Happy.
Okay. There's one question that one of our viewers have asked.
Yes.
What's his name?
Sylvester.
Sylvester keeps asking this. What happens if you get this kind of information? Let me just find it quickly. Let me write up here. What happens if you get this? 2, 3, 3, 5, 6, 6, 7. Okay? And the question is, what is the mode? Right, now if you look at it, you can see you've got 2 3s and you've got 2 6s. Guys, you can have 2 modes, eh? So the mode would be 3 and 6. So that is quite possible. All right. Normally in an exam, we don't really tend to do that because we're trying to see if you understand what mode is all about. But it could happen where you get 2 modes. Absolutely. We don't normally give you 3 or 4 modes.
Sure.
That just normally never, ever, ever, hardly ever happens.
So-
okay.
so
in
Peter-
fact, if you get a number of modes and we say there is no mode.
So, Peter, you don't find the average
No,
between the
not at
modes.
all.
Ever, ever, ever.
No. So you're not going to say there's a mode of 3 and a mode of 6. Let's find the average.
Yeah.
3 plus 6 is 9. Divide by 2 is 4.5. Hey, the mode's 4.5.
Yeah,
Rubbish.
no, that
There's no
doesn't work.
4.5
Okay.
here at all.
Okay.
Got that?
Awesome.
Okay. I hope that answers your question, Sylvester. And thanks for writing in and asking us that. That's absolutely fantastic. Okay. Let's move on to our next question. Let's try and move on to our next question. Okay, here it is here. Right, so below is a graph that indicates the average rainfall for 2 cities in South Africa. All the figures indicated have been rounded to the nearest 10 millimeters. Now, folk, I'm not going to have time to do this whole question, but there's just something I want to point out because it has come up in the past, and so I want to look at this very quickly, and that's this. This whole thing of something being rounded to the nearest 10. Okay. So let's have a look at City 1. City 1 is indicated by our blue shading here. And City 1 says we've had 20 millimeters of rainfall in January. Now, does that mean they've had exactly 20 millimeters of rain? Well, it could mean that. But it doesn't necessarily mean that because that figure has been rounded to the nearest 10. And so what I'm going to do is I'm going to write the following. And I'm going to say, I'm going to have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, that's a 20 by the way, 24, 25, 26, 27, 28, 29, and 30. Okay, so sorry about that. They seem to have run out of board space. If I'd kept writing, I would have been down on this side over here, and you wouldn't have seen this anyway. Okay, so what we want to know is this. If I've rounded something to 20, okay, so let's use a different color here. I've rounded it to 20. Is 19 closer to 20 or 10? It's closer to 20. So I could have had 19 millimeters of rain. In fact, I could have had anything from 15 millimeters all the way to 24 millimeters. Because if I had 25, it would have been rounded to 30. If I had 14 mils, it would have been rounded to 10. 15 gets rounded to 20, and 24 gets rounded to 20. So if I say on average you got 10 millimeters, but it's been rounded, it means anything from 15 all the way to 24 millimeters. Hope that makes sense, because that's a difficult concept to understand. Our challenge question. Let's have a look at it. Right, so we now have 9 numbers. So folk, what I'm going to do is I'm going to draw my 9 digits. I'm going to try and draw my 9 digits. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, and I'm going to change colors straight away. The first fact I'm told is this. The minimum value is 17. So let's write that in straight away. My minimum value was 17. What else do I know? I'm also told that the range is 33. So if the range is 33, I know 17 being the lowest, I can go up 33. And if I go up 33, I'm going to get to 50. So by telling me the range, they've actually told me the maximum number. And 17 plus 33 is going to give me the 50. Right. So we've dealt with that. The next thing, the median is 35. Remember, median is middle. So it's 35. So let's find the middle. 1, 1, 1, 1, 1, 1, 1, 1. Here it is over there. Okay? So I've now got 35 as my median. and there it is over there. Quartile 3 is 42. What is quartile 3? Do you remember quartile 1 is the middle of the middle and the lowest? So this here would be my quartile 1. Quartile 3 is this figure over there, which is the middle of the middle and the highest. And the middle of the middle and the highest is 42. So I know this figure is 42. I'm now told the interquartile range is 20. In other words, the difference between quartile 3 and quartile 1 is 20. So if that's 42, this over here has got to be 22. Done. The mode is 22. There are 3 numbers in the mode. So guys, I've got 3 22s. And if they're in order, I've got 17, I've got 35. I've only got 3 numbers in between, and they've all got to be 22. Because I've got a mode of 22. I've got 3 of them. So 22s can only fit in over here. This is wonderful, eh? This is like doing a Sudoku. It really gets your blood going. It's fantastic stuff. The next thing we're told is this, that the mean is 42. And one of the numbers is 45. Now, 45 can't go in here because it'll be lower than 42. So we're putting it between the 42 and the 45. Now, all these numbers have to have a mean of 42. In other words, folk, if I add up all these digits, and I'm very aware of my time, so let's look at this. I'm going to add all that up. My mean is my total over the number of figures I have. I'm told that my mean has to be 42. The total I'm going to add. So I'm going to say 17 plus the 22 plus everything all the way up to 50 plus my missing number. And I'm just going to call it A. We'll call that A. Okay? Over the number of figures. And we've got 9 of them. So looking at my calculator, I'm going to say I've got 42 times 9, which gives me 378. So I've got 378. And that's going to equal to adding up all those numbers. So I've got about a minute to go. So let's really get this done quickly. So let's add them up. I got 17 plus 22 plus 22 plus, oops, we forgot a 22, plus 22 plus 35 plus 42 plus, what's after 42? 45 and 50. 45 plus 50 equals, and I get 255. So I've got 255 plus A. Now what do I do? I'm now going to subtract the 375 minus 378. Okay, I think I've made a mistake with my adding here. I've gone so quickly now, I've actually messed it up because I now get an answer of 123, which shouldn't be the case. So, guys, you can't rush through that, hey? Otherwise, you tend to make careless mistakes, and that's exactly what I've gone and done.
That's okay. I think
but we'll post the right answer up on the board. Okay.
Yes.
Guys, I'm sorry I rushed.
That's okay,
over to
Peter.
you.
That's okay, because most of you learners actually got it correct and you're on the right track. Guys, thank you so much for an awesome show from us. Good night. See you next time. Bye.